students, and welcome to part 2 of lesson 3 on simplifying square roots. In this video, we are going to do 2 additional examples and summarize our learning. Here is our first example. We have 2 times the square root of 45. Now, do you see the 2 times in front? Just carry it along until step 4 where we have to simplify. So our first step is going to remain the same and rewrite the radicand as its prime factorization. Well, we know that 45 is the same as 9 times 5. 9 is the same as 3 times 3. So we have our prime factors of 3, 3, and 5. So we'll rewrite the radicand as 3 times 3 times 5 since it has the same value as 45. So we have 2 times 3 times 3 times 5. Now, step 2, look at the prime factorization and look for pairs of factors. Those will form perfect square roots. Well, we see a pair of factors here, 3 times 3. We know that 3 times 3 is 9, so the square root of 9 we can bring out of our square root symbol because it equals a whole number, 3. So we have 2 times, so we bring that down, 2 times 3, which will be in front of the square root symbol because the 3 made a perfect square root. And then inside remains the 5 because it did not have a pair. It cannot be simplified. Step 4 is to simplify. We have 2 times 3, which is 6. 6 times the square root of 5. 2 times the square root of 45 has exactly the same value as 6 times the square root of 5. That's the simplified form of 2 times the square root of 45. Let's now simplify 6 times the square root of 100. First step, rewrite the radicand as its prime factorization. 100 is the same as 10 times 10. 10 times 10 is 2 times 5, and 2 times 5, which are all prime numbers. So 100 is the same as 2 times 2 times 5 times 5. Rewrite the radicand as the prime factorization 6 times 2 times 2 times 5 times 5. 2 times 2 is a pair of factors that we can bring out because it's the square root of 4. The square root of 4 is 2. We also have another pair of factors, 5 times 5, which is 25. The square root of 25 is 5. Now, if you look at what we just did, we brought all the factors out. And if you think about this, and you may have realized at the beginning, the square root of 100 is a perfect square root, which is 10. 2 times 5 is 10. So if you don't notice that a square root is perfect, this method still works. 6 times 10 is 60. Not every simplified square root will still have a square root with it. So let's summarize simplifying square roots. First, what does it really mean to simplify a square root? That means that there are no pairs of factors left in the radicand. Second, how do I simplify a square root? Well, remember, first, write the radicand as its prime factorization. Then identify any pairs of prime factors in the radicand. Bring those numbers out since they are perfect square roots. Simplify, and then write your final answer. Last, how does this relate to prime factorizations and perfect square roots? A prime factorization helps us to identify perfect square roots in the radicand and helps us to quickly know which numbers we can bring out because they equal perfect square roots. See you in class.